An electric vehicle, also referred to as an electric drive vehicle, uses one or more electric motors or traction motors for propulsion. An electric vehicle may be powered through a collector system by electricity from off-vehicle sources, or may be self-contained with a battery or generator to convert fuel to electricity. EVs include road and rail vehicles, surface and underwater vessels, electric aircraft and electric spacecraft. EVs first came into existence in the mid-19th century, when electricity was among the preferred methods for motor vehicle propulsion, providing a level of comfort and ease of operation that could not be achieved by the gasoline cars of the time. The internal combustion engine has been the dominant propulsion method for motor vehicles for almost 100 years. But electric power has remained commonplace in other vehicle types, such as trains and smaller vehicles of all types. History. Electric motive power started in 1827, when Slovak-Hungarian priest Enius Jedlik built the first crude but viable electric motor, provided with stator, rotor and commutator, and the year after he used it to power a tiny car. A few years later, in 1835, Professor Sibrandus Strating of University of Groningen, the Netherlands, built a small-scale electric car, and a Robert Anderson of Scotland is reported to have made a crude electric carriage sometime between the years of 1832 and 1839. Around the same period, early experimental electrical cars were moving on rails, too. American blacksmith and inventor Thomas Davenport built a toy electric locomotive powered by a primitive electric motor in 1835. In 1838, a Scotsman named Robert Davidson built an electric locomotive that attained a speed of 4 miles per hour. In England, a patent was granted in 1840 for the use of rails as conductors of electric current, and similar American patents were issued to Lilly and Colton in 1847. Between 1832 and 1839, Robert Anderson of Scotland invented the first crude electric carriage, powered by non-rechargeable primary cells. By the 20th century, electric cars and rail transport were commonplace, with commercial electric automobiles having the majority of the market. Over time, their general-purpose commercial use reduced to specialist roles, as platform trucks, forklift trucks, ambulances, tow tractors and urban delivery vehicles, such as the iconic British milk float. For most of the 20th century, the UK was the world's largest user of electric road vehicles. Electrified trains were used for coal transport, as the motors did not use precious oxygen in the mines. Switzerland's lack of natural fossil resources forced the rapid electrification of their rail network. One of the earliest rechargeable batteries, the nickel-ion battery, was favored by Edison for use in electric cars. EVs were among the earliest automobiles, and before the preeminence of light, powerful internal combustion engines. Electric automobiles held many vehicle land speed and distance records in the early 1900s. They were produced by Baker Electric, Columbia Electric, Detroit Electric, and others, and at one point in history outsold gasoline-powered vehicles. In fact, in 1900, 28% of the cars on the road in the USA were electric. EVs were so popular that even President Woodrow Wilson and his Secret Service agents toured Washington, D.C. in their Milburn Electrics, which covered 60 to 70 miles per charge. A number of developments contributed to decline of electric cars. Improved road infrastructure required a greater range than that offered by electric cars, and the discovery of large reserves of petroleum in Texas, Oklahoma, and California led to the wide availability of affordable gasoline, making gas-powered cars cheaper to operate over long distances. Also, gasoline-powered cars became ever easier to operate thanks to the invention of the electric starter by Charles Kettering in 1912, which eliminated the need of a hand crank for starting a gasoline engine, and the noise emitted by ICE cars became more bearable thanks to the use of the muffler, which Hiram Percy Maxim had invented in 1897. As roads were improved outside urban areas, electric vehicle range could not compete with the ICE. Finally, the initiation of mass production of gasoline-powered vehicles by Henry Ford in 1913 reduced significantly the cost of gasoline cars as compared to electric cars. In the 1930s, National City Lines, which was a partnership of General Motors, Firestone, and Standard Oil of California, purchased many electric tram networks across the country to dismantle them and replace them with GM buses. The partnership was convicted of conspiring to monopolize the sale of equipment and supplies to their subsidiary companies, but were acquitted of conspiring to monopolize the provision of transportation services. Experimentation. In January 1990, General Motors president introduced its EV concept two-seater, the Impact, at the Los Angeles Auto Show. That September, the California Air Resources Board mandated major automaker sales of EVs, in phases starting in 1998. From 1996 to 1998, GM produced 1117 EV1S, 800 of which were made available through 3-year leases. Chrysler, Ford, GM, Honda, Nissan and Toyota also produced limited numbers of EVs for California drivers. In 2003, upon the expiration of GM's EV1 leases, GM crushed them. The crushing has variously been attributed to the auto industry's successful federal court challenge to California's zero-emissions vehicle mandate, a federal regulation requiring GM to produce and maintain spare parts for the few thousand EV1S, and the success of the oil and auto industry's media campaign to reduce public acceptance of EVs. A movie made on the subject in 2005-2006 was titled Who Killed the Electric Car, and released theatrically by Sony Pictures Classics in 2006. The film explores the roles of automobile manufacturers, oil industry, the U.S. government, batteries, hydrogen vehicles, and consumers, and each of their roles in limiting the deployment and adoption of this technology. Ford released a number of their Ford EcoStar delivery vans into the market. Honda, Nissan and Toyota also repossessed and crushed most of their EVs, which, like the GM EV1S, had been available only by closed-end lease. After public protests, Toyota sold 200 of its RAV EVs to eager buyers. They later sold it over their original $40,000 price. This lesson did not go unlearned. BMW of Canada sold off a number of mini EVs when their Canadian testing ended. The production of the Citroën Berlingo Electrique stopped in September 2005. Reintroduction during the last few decades. Environmental impact of the petroleum-based transportation infrastructure, along with the peak oil, has led to renewed interest in an electric transportation infrastructure. EVs differ from fossil fuel-powered vehicles in that the electricity they consume can be generated from a wide range of sources, including fossil fuels, nuclear power, and renewable sources such as tidal power, solar power, and wind power, or any combination of those. The carbon footprint and other emissions of electric vehicles varies depending on the fuel and technology used for electricity generation. The electricity may then be stored on board the vehicle using a battery, flywheel, or supercapacitors. Vehicles making use of engines working on the principle of combustion can usually only derive their energy from a single or a few sources, usually non-renewable fossil fuels. A key advantage of hybrid or plug-in electric vehicles is regenerative braking due to their capability to recover energy normally lost during braking, as electricity is stored in the onboard battery. As of September 2014, update. Series production highway-capable all-electric cars available in some countries for retail customers include the Mitsubishi i-MiEV, Chery QQ3 EV, Jack J3 EV, Nissan Leaf, Smart Ed, BYD E6, Bolloré Blue Car, Renault Fluence ZE, Ford Focus Electric, Tesla Model S, Honda Fit EV, RAV4 EV second generation, Renault Zoe, Roe 50, Mahindra E20, Chevrolet Spark EV, Mercedes-Benz SLS AMG electric drive, Fiat 500, Volkswagen e-Up, BMW i3, Kia Soul EV, Volkswagen e-Golf, Mercedes-Benz B-Class electric drive and Venucia E30. As of early December 2015, the Leaf, with 200,000 units sold worldwide, is the world's top-selling highway-capable all-electric car in history, followed by the Tesla Model S with global deliveries of about 100,000 units. As of May 2015, update, more than 500,000 highway-capable all-electric passenger cars and light utility vehicles have been sold worldwide since 2008. Out of total global sales of about 850,000 light-duty plug-in electric vehicles. As of May 2015, update, the United States continued to have the largest fleet of highway-capable plug-in electric vehicles in the world, with about 335,000 highway-legal plug-in electric cars sold in the country since 2008, and representing about 40% of the global stock. California is the largest plug-in car regional market in the country, with almost 143,000 units sold between December 2010 and March 2015, representing over 46% of all plug-in cars sold in the U.S. Norway is the country with the highest market penetration per capita in the world, with 4 plug-in electric vehicles per 1,000 inhabitants in 2013. In March 2014, Norway became the first country where over 1 in every 100 passenger cars on the roads is a plug-in electric. Norway also has the world's largest plug-in electric segment market share of total new car sales, 13.8% in 2014, up from 5.6% in 2013. As of May 2015, update, there were 58,989 plug-in electric vehicles registered in Norway, consisting of 54,160 all-electric vehicles and 4,829 plug-in hybrids. Lithium-ion battery. Most electric vehicles use lithium-ion batteries. Lithium-ion batteries have higher energy density, longer lifespan and higher power density than most other practical batteries. Complicating factors include safety, durability, thermal breakdown and cost. Li-ion batteries should be used within safe temperature and voltage ranges in order to operate safely and efficiently. Increasing the battery's lifespan decreases effective costs. One technique is to operate a subset of the battery cells at a time and switching these subsets. Electric motor. The power of a vehicle electric motor, as in other vehicles, is measured in kilowatts. 100 kilowatts is roughly equivalent to 134 horsepower, although most electric motors deliver the full torque over a wide RPM range, so the performance is not equivalent, and far exceeds a 134 horsepower fuel-powered motor, which has a limited torque curve. Usually, direct current electricity is fed into a DC, AC inverter where it is converted to alternating current electricity, and this AC electricity is connected to a 3-phase AC motor. For electric trains, forklift trucks, and some electric cars, DC motors are often used. In some cases, universal motors are used, and then AC or DC may be employed. Vehicle types. It is generally possible to equip any kind of vehicle with an electric powertrain. Ground vehicles. Plug-in electric vehicle. A plug-in electric vehicle is any motor vehicle that can be recharged from any external source of electricity, such as wall sockets, and the electricity stored in the rechargeable battery packs drives or contributes to drive the wheels. PEV is a subcategory of electric vehicles that includes all electric or battery electric vehicles, plug-in hybrid vehicles, and electric vehicle conversions of hybrid electric vehicles and conventional internal combustion engine vehicles. By mid-September 2015, over 1 million highway-capable plug-in electric passenger cars and light utility vehicles have been sold worldwide. By early December 2015, the world's top-selling plug-in electric cars are the Nissan Leaf, with global sales of 200,000 units, followed by the Chevrolet Volt plug-in hybrid, which together with its sibling the Opel, Vauxhall Ampera has combined global sales of about 104,000 units. The all-electric Tesla Model S with about 100,000 units sold worldwide, the Mitsubishi Outlander PHEV with about 85,000 units, and the Prius plug-in hybrid with about 75,000 units. Hybrid EVs. A hybrid electric vehicle combines a conventional powertrain with some form of electric propulsion. As of July 2015, update, over 10 million hybrid electric vehicles have been sold worldwide since their inception in 1997. Led by Toyota Motor Company with over 8 million Lexus and Toyota hybrids sold as of July 2015, update, followed by Honda Motor Co., Limited, with cumulative global sales of more than 1.35 million hybrids as of June 2014, update, Ford Motor Corporation with over 424,000 hybrids sold in the United States through June 2015, Hyundai Group with cumulative global sales of 200,000 hybrids as of March 2014, update, including both Hyundai Motors and Kia Motors hybrid models, and PSA Peugeot Citroën with over 50,000 diesel-powered hybrids sold in Europe through December 2013. The Toyota Prius liftback is the world's top-selling hybrid with more than 3 million units sold by June 2013. On and off-road EVs are on the road in many functions, including electric cars, electric trolleybuses, electric buses, electric trucks, electric bicycles, electric motorcycles and scooters, neighborhood electric vehicles, golf carts, milk floats, and forklifts. Off-road vehicles include electrified all-terrain vehicles and tractors. Rail-borne EVs. The fixed nature of a rail line makes it relatively easy to power EVs through permanent overhead lines or electrified third rails, eliminating the need for heavy onboard batteries. Electric locomotives, electric trams, streetcars, trolleys, electric light rail systems, and electric rapid transit are all in common use today, especially in Europe and Asia. Since electric trains do not need to carry a heavy internal combustion engine or large batteries, they can have very good power-to-weight ratios. This allows high-speed trains such as France's double-deck TGVs to operate at speeds of 320 km per hour or higher, and electric locomotives to have a much higher power output than diesel locomotives. In addition, they have higher short-term surge power for fast acceleration, and using regenerative brakes can put braking power back into the electrical grid rather than wasting it. Maglev trains are also nearly always EVs. Space rover vehicles. Manned and unmanned vehicles have been used to explore the Moon and other planets in the Solar System. On the last 3 missions of the Apollo program in 1971 and 1972, astronauts drove silver oxide battery-powered lunar roving vehicles distances up to 35.7 kilometers on the lunar surface. Unmanned, solar-powered rovers have explored the Moon and Mars. Airborne EVs. Since the beginning of the era of aviation, electric power for aircraft has received a great deal of experimentation. Currently flying electric aircraft include manned and unmanned aerial vehicles. Seaborne EVs. Electric boats were popular around the turn of the 20th century. Interest in quiet and potentially renewable marine transportation has steadily increased since the late 20th century. As solar cells have given motorboats the infinite range of sailboats, electric motors can and have also been used in sailboats instead of traditional diesel engines. Electric ferries operate routinely. Submarines use batteries, nuclear power, fuel cells or Stirling engines to run electric motor-driven propellers. Electrically powered spacecraft. Electric power has a long history of use in spacecraft. The power sources used for spacecraft are batteries, solar panels and nuclear power. Current methods of propelling a spacecraft with electricity include the arc jet rocket, the electrostatic ion thruster, the Hall effect thruster, and field emission electric propulsion. A number of other methods have been proposed, with varying levels of feasibility, energy and motors. Most large electric transport systems are powered by stationary sources of electricity that have directly connected to the vehicles through wires. Electric traction allows the use of regenerative braking, in which the motors are used as brakes and become generators that transform the motion of, usually, the train into electrical power that is then fed back into the lines. This system is particularly advantageous in mountainous operations, as descending vehicles can produce a large portion of the power required for those ascending. This regenerative system is only viable if the system is large enough to utilize the power generated by descending vehicles. In the systems above, motion is provided by a rotary electric motor. However, it is possible to unroll the motor to drive directly against a special match track. These linear motors are used in maglev trains which float above the rails supported by magnetic levitation. This allows for almost no rolling resistance of the vehicle and no mechanical wear and tear of the train or track. In addition to the high-performance control systems needed, switching and curving of the tracks becomes difficult with linear motors, which to date has restricted their operations to high-speed point-to-point services.